Hi, everybody. Welcome to our Microsoft Reactor event for today. I'm going to hand it over to Brandon, our speaker for today, in just a minute, but I wanted to go over a few announcements. First of all, we do have the live event Q&A set up, so if you have a question, please feel free to put it in there. You should see an icon that looks like two text boxes, and the top text box has a question mark in it. That is going to be the live event Q&A. We will also be sharing some links there. I'll share links to our Reactor meetup pages where you can find other events we have coming up. I will share links to our YouTube page where the recording of this session as well as our other sessions will be located. And then finally, I'll share a link to our survey. If you do have a few minutes today and you can take the survey, that would be great. And now I will pass it over to Brandon.
All right. Well, thanks, Dion. Thanks for having me today. And welcome, everybody. And thanks for joining me. In this session, we'll be talking all about Xamarin and specifically how we create native iOS and Android apps in .NET, in C# using Xamarin. My name is Brandon Minnick. I work as a developer advocate here at Microsoft. I've been in C# for about 10 years now and been writing Xamarin apps for about 5 years now. I actually used to work at Xamarin, and back when we were just a small startup based out of San Francisco, then Microsoft came along and acquired us, which is how I landed here at Microsoft. And so before we jump into it today, I want to point out two links that you'll see on the bottom of just about every slide. On the bottom left, this is my Twitter handle, The Code Traveler. If you have any questions, this is the best way to get in contact with me. Obviously, we have the Q&A going on today, but maybe you didn't have time to ask the question, or you woke up in a cold sweat in the middle of the night and you wanted to get more Xamarin information. Feel free to shoot me a message anytime. My direct messages are always open. And on the bottom right, this is a landing page, a website that I put together just for this session, just for today, where you can find all the topics we're going to talk about. So don't worry about memorizing anything. If you follow that link, it'll take you to a web page where you can see the slides for today. I've linked to previous recordings of this talk, so if you have any friends or coworkers who couldn't make it, you can share that with them. We are also going to be looking at a couple open source sample apps or demos today, and those are all open source on GitHub. I've linked those on the website. And if you want to learn more about Xamarin, I've also included a bunch of links about getting started and where to go. So that is your wealth of knowledge. Make sure to open the link, click on it, or bookmark it, share it with your friends and colleagues, and let's get going. Now, to kind of understand what Xamarin is, why Xamarin exists, it's helpful to know the history of architecting mobile apps. And if we go way back in the day, way back when, say, iOS and Android were still pretty new, so probably about 10 years ago, if you wanted to create an iOS app and get that into the App Store, you had to create that app in Objective-C, and you had to write all that Objective-C code in Apple's developer tools called Xcode. And if you wanted to create that same app for Android, well, then you would have to rewrite the entire thing in Java using Android Studio, which is Google's development tool, even though it's the same app. So even though it looks and feels similar, even though it's going to have the same functionality and same colors and same navigation, that app had to be recreated twice. And likewise, if you also wanted that app to run on Windows, you would have to, again, rewrite the whole thing a third time in C# using Visual Studio. And this meant, well, it means a couple things. It means that you aren't sharing any code between your iOS and Android apps. So that means all that code you wrote for iOS has to be recreated, rewritten for your Android app. And all these bug fixes you might find for Android, well, you have to first then go back to your Android code base, or I'm sorry, go back to your iOS code base and see, does that bug even exist? If it does, how do we fix it over here? They both follow, iOS and Android both follow different architecture paradigms. So not only is it different code, but it's differently structured with different architectures, and it's a pain. That being said, it's still very much a valid way to create iOS and Android apps today. A lot of companies still choose to go this route, albeit those companies are usually rich. They usually have a lot of money, because that means they have to have a developer team for iOS that writes in Objective-C or Swift. They have to have another developer team for Android that writes in Java or Kotlin. And if they do port it over to Windows, then they'll have to have a third developer team that knows C#. And so it's definitely one way to do it, but you don't get any benefit from having the same app twice in two different code bases, other than you're still using all of the native tools, and you never really have to worry about any ever being behind or any obsolescence or missing out on anything, because you're still going to use Apple's tools, Android's or Google's tools. But after a while, we kind of realized, like, there's got to be a better way, right? We're just recreating the same app twice. We are fixing bugs on both platforms. Anytime we want to add a new feature, we have to add it in two places. And that's when the creators, the founders of Xamarin, came up with this approach, where what if we do it all in C#? And then we can share code between our iOS and Android apps, because they're just written in C#. So we can just share that C# code. And there's still a couple platform-specific APIs, like on iOS and Android, to create UIs. They have unique APIs. And yeah, there's still a little bit of code separated between iOS and Android, but now we're sharing the majority of our code, which means we can create our apps more quickly. When we find a bug, we only have to fix it once, and it's fixed forever. When we add new features, we only have to fix them, or we only have to add them once. And the best part about Xamarin is it still gives you a native app, and it's able to do that because all Xamarin does is it wraps every single Objective-C API on iOS and exposes them to us in C#. And likewise for Android, it takes every single Java API and exposes those to us in C#. So if you've ever done any iOS development or any Android development, Xamarin's going to feel very similar, because you're calling all the same APIs. The only difference is we're writing our code in C# instead of Objective-C or Swift, and we're writing our code for Android in C# instead of Java or Kotlin. And then the benefit there is, because it's in C#, we can share those codes. We can share that code between those apps. So we're able to share code. We're able to get our apps to market more quickly. We're able to fix bugs more quickly, and you get the same performance of a native app because it is totally native. We're using the same native APIs. When we compile, our app compiles down into the native binary. Your phone doesn't know the difference. It is a fully native app, but now we get to write it in C#. Now, you might think we're only talking about iOS apps, or iPhone apps, Android apps, but because Xamarin wraps all of the APIs, there's really no limits to what you can do if you choose to use C# with Xamarin. You can create Apple Watch apps, Apple TV apps, Android Wear, and that's because you have access to every single native API. It's pretty much, or say literally the same thing, just for writing in C# instead of Java, Kotlin, Objective-C. And so with Xamarin, everything you can do in Objective-C, Swift, Java, or Kotlin can be done in C# with Xamarin. Now, one cool thing about Xamarin is it is completely open source. So if you ever want to, you can check out all of the code for Xamarin on GitHub. I've included a link to the Xamarin repos on the link in the bottom right. So if you go to codetraveler.io/Xamarin-conf, you'll find all the links to Xamarin iOS, Xamarin Android, and you can check out how we create it, how we wrap all the APIs. Or if you found a bug, you can file it there, you can fix it, you can open a pull request, you can add features, you can do whatever you want because it's totally open source. And Xamarin allows you to use either Windows or Mac to create your apps. So if you have a PC and you're familiar with Visual Studio, you can create your iOS and Android apps there in Visual Studio. Or if you're like me, I'm on a Mac right now, you can choose to use Visual Studio for Mac and create your Xamarin apps in Visual Studio for Mac. It's the same exact code. So for example, I work on a couple apps, and some of us on the team use Macs, some of the team use PCs, and we share the same exact code between the two. So it's more of just a personal preference. If you prefer your PC or your Mac, we've got both scenarios covered. All right, well, enough talking about it. Let's actually jump into a demo. Let's check out some code. So I have an app here called Image Search, and let's go ahead and bring up all of our simulators here. There we go. So this is an app called Image Search, and it's created using Xamarin. And before we jump into the code, just give you a quick tour of the app. It's pretty simple, just one page. You can type anything into the search bar, and when we click go, it'll use the Bing's image search APIs and pull down all the images for whatever we search for. So we're searching for Xamarin there. We can also search for .NET, and we'll get the results back here in a list. And something you'll notice right away is we have the iOS app here, we have the Android app here, and they're created in Xamarin, and they look and feel native. And that's because they are, because we're using the native APIs, and both apps have a similar look and feel, but we're able to share a lot of this code between the two apps. So anything that's not platform specific, like this code that we just called to reach out to the Bing APIs, that's just C# logic, what we call business logic. And we can share that code, and we did. So let's actually jump over to the code here and check out what's going on. In Visual Studio for Mac, you'll notice I have 3 projects in this solution. I have my imagesearch.droid, imagesearch.ios, and imagesearch.shared. So in the Android project, this is where all of those Android APIs live. So like we mentioned earlier, Xamarin just wraps all of the Java APIs and brings them to us in C#. And so if we jump into something like the main activity, if you've ever created a Android app before, you'll notice that this feels really familiar. So things like activities, things like image adapters, recycler views, all of this are Android APIs. We're just able to now do it in C#. And likewise, if you've created that app in Android app in Java or Kotlin before, you've also played around with Android's XML. I actually have this, there we go, open right here. So for Android, and this is actually the same, if you were creating your app in Java or Kotlin, you would write this same exact XML. You could take this XML file and dump it into a project written in Kotlin or Java, and it would still work because it's the same thing. Android gives us a designer here where we can do drag and drop. So if we wanted to move the button to the side, we can do that. And you'll notice when I move the button that the XML code here on the right actually shifts. Let's see, boop. So there's a button in the progress bar switching places. And if you prefer to write in code instead of using the visual designer, you can do that as well. So I could come over here, instead of saying search for the button, I could say go. And we can see the UI update in real time. And like I said, this is the exact same way we would do it if we were creating it or creating it in Android Studio using Java or Kotlin. It just so happens to be now we're using Xamarin and C#. Similar story over on iOS. So on the iOS, in this iOS project, this is where all the iOS APIs live. And so if you've ever created an app for iOS using Swift or Objective-C, you'll recognize a lot of this code looks familiar, like UI view controllers, having methods like viewDidLoad, getItemsCount. This is all native iOS code, all native iOS APIs that we're able to interact with here in C#. And for UIs in C#, I'm sorry, for UIs in iOS, we use what are called storyboards. And what's really cool with storyboards is kind of like we just saw for Android, that XML layout. iOS uses storyboards that have their own drag and drop designer. And when I launch this file, it'll actually open up in Xcode. And so let's go ahead and click on main.storyboard here. Give it all a second. So yes, it did open up in Visual Studio. This is actually something that will be going away soon. Let's see, let me show you these side by side. Let's do this and let's do, where's Xcode? There it is. This. Make everything a little bit bigger. There we go. So what's going on here? Well, in Visual Studio, the Xamarin team has been essentially keeping up with the Joneses, has been creating their own storyboard designer inside Visual Studio. The real storyboard designer is here in Xcode. And similar with what we were just doing on Android, this is just a drag and drop designer where we can move and place buttons on the screen. We can move this search bar around. And of course, it's going to yell at me for doing that, but it's a visual designer. And in Visual Studio here on the left, we've had a storyboard editor for a while. Oh, look at that. It even changed after I updated Xcode because it's the same file. But we've actually started to deprecate the storyboard designer in Visual Studio, mostly because, like I said a minute ago, we're just keeping up with the Joneses. This in Visual Studio was just talking to Xcode behind the scenes using some scripts. And what we found was we were always just falling behind. Every time Xcode would come out with a new feature, new interface in their storyboard designer, we would have to bring that into Visual Studio. And we said, you know what? Let's just let everybody use Xcode. Xcode's always going to be the greatest storyboard designer. Let's not reinvent the wheel. But for now, we do have this this fun overlap where there's both. But right, so if you've ever created an iOS UI before, you're probably familiar with the storyboard editor. Like we saw a minute ago, this is where you can drag and drop and move things around. You can add buttons to the screen. And as soon as you do that, those results will percolate back into Visual Studio, just like we saw. Oh, there's the changes. So it's literally the same file. Like you could take a storyboard file from an existing iOS app that maybe you wrote in Xcode with Objective-C. You could drop it into your Xamarin project, and it's going to be the same thing. So we have our storyboard here. That's how we create our UI. This is all great. Should feel really familiar if you've ever created iOS or Android apps before using the native tools. But this is where the benefit comes from, this image search.shared project, because this project is shared between both iOS and Android. So let's pop this open. So for example, I have this image search service here, and this is actually the code that runs when we click the search button. So that search button on iOS uses this code. That same search button on Android uses this code. And this is what we call our business logic, because this is just C# code that's performing something when the user clicks a button. And in this case, we're calling out to the Bing API and telling us to get all the search images that match whatever text the user put in. And likewise, we have a view model here. If you're familiar with the MVVM architecture, model view view model, this view model is being shared by both iOS and Android. And likewise, it has the logic in here to, let's see, get the images from that image search service. It'll filter them to make sure that they all contain HTTPS, and then it'll clear any images that were already on the screen and replace them with our new filtered images. And so this is great because now this code is shared between iOS and Android. So if we wanted to tweak our logic for how we're searching, maybe we got a 1-star review in the App Store, right? Somebody says, anytime I search using an emoji, your app crashes. And so we can come in here and add some logic to say, if this is an emoji, make sure to handle it instead of crashing the app or something crazy like that. So with Xamarin, it's very similar. We still have all of our native Android APIs. We have our native iOS APIs, and then we can share all of the business logic between them so that when we find bugs, we can fix them in one place. If we want to add new features, it becomes super easy because we only have to add in that business logic once for both apps, and then we're done. All right, so that was how we can still use all the native APIs on iOS and Android to create our user interface and share that business logic code between them. But you'll notice we weren't sharing any of that UI code. The Android UI was built using the Android XML files. The iOS UI was built using the Storyboard Designer. And that's just because iOS and Android use different APIs for their UI. So for example, on iOS, if you want to create a button, iOS calls that a UI button. And on Android, that same button is called an Android widget button. And so for the longest time, we had to create those separately. But after a while at Xamarin, we started to think, there's got to be a better way. And that's when we came up with the idea for Xamarin Forms. Now, Xamarin Forms is a UI toolkit that runs on top of Xamarin that allows you to share your UI code. Now, the way Xamarin Forms works, it will take that button. So I'll tell Xamarin Forms, put a button on the screen. And then when I compile down for iOS, that button in Xamarin Forms will compile down into the native UI button on iOS. So we still get the native button that we'd expect if we say we're doing our UI the old way with storyboards. And likewise on Android, that Xamarin Forms button compiles down to an Android widget button. So again, we still get the native Android UI because we're still compiling down to the native Android APIs. So with Xamarin Forms, we're now able to share even more code, which means we can make our apps even faster because we're almost creating our iOS app and our Android app, and Windows, if we're targeting Windows apps, we can create all three apps at the same time using the same Xamarin Forms code, and it's still all native, which is really cool. So what does this look like, right? Well, here are iOS, Android, Windows Phone, all running off of the same code I wrote in Xamarin Forms. So this code here on the right is written in Xamarin Forms, and that same code you can see compiles down to the native UI. So on iOS, or actually across all three of them, again, they look and feel very similar, but they're still distinctly native. So iOS still follows the what they call the human interface design guidelines, where everything's very flat. We have rounded edges. We have our tabs on the bottom here with our icons, and it looks native because it is native. And likewise on Android, it follows the material design guidelines, where everything's a little bit more edgier. So we have shadows under our buttons that are a little bit more boxy with square corners. Our text boxes are underscores, and the tabs are at the top. Now, that's only because when Android first came out, the default for tabs on Android was the top. A couple years ago, they said, yeah, we changed our mind. We recommend tabs on the bottom. You can still put tabs on the bottom with Xamarin Forms, and I'll show you how to do that in just a minute. But let's take a look at this code here on the right, because this is how you create your UI in Xamarin Forms. So in Xamarin Forms, what we've done, we've created a new entry. Entry is just what Xamarin Forms calls a text box. So created a new entry, and I told it, for this entry, I want your placeholder to be username. So we've got a text box with a placeholder of username. Likewise, we have an entry with placeholder called password. And then we also have a button whose text is login, and its background color is this green. It is green based off of this text value. And then to display these three UI elements on the screen, we have to lay them out. We have to choose some sort of layout. And so I went with the stack layout, which just stacks one on top of the other in the order in which we add them. So create a stack layout that's going to be centered in the screen. And I've added the username entry first, which is why the username entry appears on top, then the password entry, then the login button. And so once we put these inside of a layout, we can put them on the page. And in Xamarin Forms, those are called content pages. So a content page is basically just anything that takes up the whole screen here. So it's full screen content page. So we created our profile page where I told it, gave it a title of profile, gave it an icon image source. And I said for the profile page, your content is going to be that stack layout. So that stack layout right here with our username, password, login button, that goes in the profile page. We created a second page called settings page. And for the navigation in this app, we chose to use tabs. So that'll be a tab page. And similar to the layouts, the tab page has children. We added in the profile page, add in the settings page, and then set that to be our main root page of the app. So in about 30 lines of code, we've created 3 native apps across iOS, Android, and Windows. So let's jump out of the slides. Let's jump into another sample app here and see what this code really looks like. Don't save, don't save. And while that's loading, let's go ahead and launch this app here. And here. There we go. So this is an app called My Weather, and we can put in any city, state. So let's see, let's try, I see Seattle over there already. So let's do Seattle. We'll say get the weather, and then it'll return back the weather results. Likewise on Android, get the weather, and it'll get back the weather for Seattle for our Android app. And then we also have another tab here at the bottom where we can see the upcoming forecast. Now, this app was written in Xamarin Forms, so the UI code, the business logic, all the code, probably I think that's about 95% of this code base is shared between iOS and Android, thanks to Xamarin Forms. And what you'll notice is it's still, even though the code is shared, it's still very much distinctly native. Like, for example, when I click this tab on Android, you see the tab goes a little darker, kind of has that ripple effect to it. And we can also slide between apps or slide between tabs here on Android, which isn't a thing on iOS. And so even though we're sharing code, these apps are still very much native because Xamarin Forms compiles down to the native APIs. Xamarin is native. Xamarin Forms is still native. The only difference here is when we wrote the code, we only had to write the code once for both apps. So let's walk through this architecture a little bit, see how this app is designed. Let's see, let's go ahead and close all these. So the My Weather app actually runs on Android, iOS, and Windows. That's what this UWP project is. It's yelling at me because I'm on my Mac, and well, you got to be on a PC to run a Windows app, obviously. But what we have here is similar to the last app where we have an iOS project, and this is where, again, all the native iOS APIs live. But the difference this time is that we have very little code in the iOS app. This is it. We have our app delegate where we essentially just initialize a couple things like I'm initializing Xamarin Forms. I'm using a library called FF image loading, stands for fast and furious image loading. So I'm initializing that. And then I call load application new app. And that new app, this is a class that lives up here in shared code. So for iOS, I write a couple lines of code. There we are. I write a couple lines of code. And then as soon as I say new app, I've jumped into the shared code. And likewise on Android, we start in our main activity, couple lines of code. This is where we can access all the native Android APIs, but basically all we're doing is we're initializing Xamarin Forms and a couple other libraries. And again, as soon as I say new app, we've jumped into our shared code. So what does that look like, right? If we, let's do this, there we go. So here in our shared code, this is the code that's shared between both iOS, Android, and UWP. We are creating a tab page with the title of My Weather. We have a view model here. And if you are familiar with MVVM, Model View View Model, that's the recommended way to architect your Xamarin Forms apps. We won't be diving into architecture stuff today, so if you've never heard of it, don't worry about it. But that's where the business logic lives. So Model View View Model says that we should keep all of our UI stuff in the view layer, and then we should keep all the business logic stuff in the view model layer. And then that way, if we want to ever change the UI, we can do that without changing our business logic or introducing any or breaking changes in our business logic. And likewise, if we wanted to change our business logic to keep the UI, we could do that because they're separated in different parts of the app. But we're just looking at the UI for now. So right, so we have a tab page, we have two children, the weather view, our forecast view. Like I mentioned a minute ago, Android wants you to put the tabs on the bottom now. How do you do that in Xamarin Forms? Well, one line of code. You say on Android, set the toolbar placement on the bottom. And now we've got tabs on the bottom. And let's actually look at how that page is constructed. There we go. So this, let's do that and that. There we go. So this is our weather view page. So the weather page here, or the weather tab here, I should say, we created it using a grid layout. So that example in the slides, we use a stack layout, which puts everything one on top of each other. Well, here for this app, we wanted to have some switches, some toggles in the same row. And so it's easiest to use a grid. And that's just like an XY coordinates grid, right? We're going to define some rows, we're going to define some columns, and we do that here. So we've defined a couple rows. I have a row called location input. So that's this top row up here where we can input our location. And that row is 50 pixels tall. Then we have a row called imperial switch. So that's where we have the switch that the user can toggle if we want to use imperial, or if we prefer to use metric. We have a row for our GPS switch, our get weather button, our temperature forecast, and all of these are fixed heights until we get to the conditions forecast. This is our conditions. Looks like it's raining in Seattle right now. And for that, I just said star for the height of that row. Star is basically a wildcard. We can set it to say, consume the rest of the screen. Now, likewise, for columns, we have two columns in this app. And the columns here, they're a little tough to tell because the first column is so tiny. We have a column called toggle, which is only 50 pixels wide. That column is right here. It basically just encompasses the size of these switches. And then the description column is just the rest of the screen. So once we have those rows and columns defined, then we can create our entries, our labels, our switches, and we just have to say, go in this row, go in this column. So for example, I have my entry here where we can give it a placeholder. Placeholder is the text that appears when there's no text in there. There we go. So city, country abbreviation, city, country abbreviation. And I said, this entry will go in the row location input, and we're going to span all the columns. So all two columns, just go across the whole screen there. And then, like I mentioned earlier, this app is using the MVVM architecture, the model view model architecture. And so there's no logic here in this view. This is all just defining my UI. So what happens when I enter text into this? Well, we use what are called bindings with MVVM. So we are bound to the weather view model, and there's a string down there in the view model that gets updated anytime we enter in the text. Likewise with like the get weather button down here, we created the button. We said this button's going to have text called get weather. That's going to go in the get weather button row, span all the columns, and that button has a command property. So command is basically what happens when the user taps this button. Well, the view doesn't know. The view just shouts to the view model and says, hey, the get weather command button's been tapped. And when it does, we've got code over here in another class in our view model. And that's actually executing all this logic here. So all this logic runs in the background while the view is kind of impervious to it until basically the view model says, hey, I'm all done. Update the temperature, update the condition, update the forecast. But yeah, so with Xamarin Forms, we're sharing all of this code. Almost every single line of code in this app is shared between iOS and Android. The apps are still very much native because all of this boils down to the native iOS and Android APIs, still get the same performance. And the benefit here is now we're essentially creating the same app 3 times, or we're creating 3 apps at the same time is probably a better way to put it, meaning that this one Xamarin Forms project, this one shared project, is used by Android, iOS, UWP. And so if we wanted to change anything or add a new tab, we only have to do it once, and then we get it for free on all 3 platforms. So highly recommend Xamarin Forms. It's actually what I use. I have a couple apps in the App Store that I've created just in my spare time, nights and weekends, something I do for fun. They're free apps. I don't make any money off of them. And the only way I'd be able to maintain multiple App Store apps across iOS and Android and Windows is thanks to Xamarin Forms, because really I only have to create that app once, and then I kind of get it for free on all the various platforms. Whew. All right. So been throwing a lot of stuff at you, I know. So let's do just a quick review. Xamarin is just a way to make native mobile apps using .NET. And all Xamarin does is it wraps 100% of the iOS APIs and 100% of the Android APIs. So if you're familiar with iOS and Android development, because maybe you've made an app in Swift or Java or Kotlin or Objective-C, it's going to feel very familiar to you coming to Xamarin because it's the same exact APIs. Xamarin Forms is a UI framework that runs on top of Xamarin, and that allows us to share our UI code across iOS, Android, and Windows. All right, so let's say you're super excited, you want to jump into Xamarin, but you're not sure where to start. There's a really cool service that is, we'll say, relatively new. It's only been out for about a year or so, called Microsoft Learn. And Microsoft Learn is available to anybody on the Microsoft website. And what it is interactive step-by-step exercises. So not only does it walk you through how to create your first Xamarin app, or how to create a database in your Xamarin app, or how to consume a REST API from your Xamarin app. It'll show you how to do that. It'll show you how to do it step by step. It'll give you the coding examples. And then as you finish certain what are called modules, there will be quizzes at the end just to basically help you track your progress. So as you finish a module, it'll give you a quick quiz, make sure you picked up on all the key points. And when you do that, then you get achievements. So you'll get badges, you can track your progress, you can pick up where you left off. And the best part is Microsoft Learn is totally free. So let's see, we got a little bit of time. So let's check it out. It's just microsoft.com/learn. And again, all of the links I've been sharing with you, all of the knowledge, all of that source code for the demo apps, it's all available on codetraveler.io/Xamarin-conf. So again, don't worry about memorizing everything. If you've got this URL here, you're good to go. You've got the link to Microsoft Learn. But let's see, let's go ahead and let's see, so microsoft.com/learn. And let's bump up this font size here. So once you're in Learn, you'll see there's all these different materials where you can basically learn about anything Microsoft. So if you're interested in learning stuff about Azure, if you're interested in learning stuff about like databases, Power BI, what else do we have here? Oh, cool. There's GitHub stuff, Gatsby, pretty much anything you can think of. We've got tutorials here. So great, but let's try and dig into, let's see, let's browse all the learning options and we can dig into some of the Xamarin stuff. So if we search here, there's probably a button I can filter on Xamarin, but I'm gonna be lazy. I'm just gonna type it in. Oh, there it is. Nice. All right, so we search for Xamarin and you'll see all sorts of different things. So how to create a mobile app with Xamarin Forms, introduction to Xamarin Android, all this fun stuff. Here's your SQLite databases, how to publish your app to the app stores. And let's see, I notice I am not signed in. Now I want to show you, you don't have to sign in, you don't have to create an account, but just wanted to show this to you because when you are signed in, it'll track all your progress. So apparently I'm level 6. To be honest, I don't know if that's good or bad. Hopefully it's good. But you can see all the progress, all the things you've been working on. You can pick up where you left off. And then it also has all of your achievements. So all of the courses you've completed. And you can see I've done a couple of the Xamarin ones here. But let me jump into, I think it's this one. Is this one I was thinking of? No, dang. All right, let's go back to the browse. Browse for Xamarin. So what I want to show you, there it is. Learning path, that's what I was looking for. Some of these are called learning paths and some of these are called modules. The quick thing you'll notice is a learning path has an estimated time of 9 hours and 34 minutes to complete, whereas a module, about an hour, so 59 minutes. Let me click into this learning path and show you why that is and what that means. So learning paths are comprised of modules. So a learning path, this is where you can start. You can know nothing about Xamarin, and if you follow this step by step, you will be a Xamarin expert and know how to publish your apps to the app stores. But what it does, it combines these modules for us. So yeah, the learning path, estimated time, 9 hours and 34 minutes to complete. But we have these modules here that give it to us in bite-sized chunks. So even this module that is 59 minutes to complete is broken down into separate units. So we can do things like, we can do the introduction, 2 minutes, no problem. I can do that in between meetings. Create a Xamarin Forms project in Visual Studio, easy, 12 minutes. I can do that on my lunch break. And so just to show you what these look like, here's the introduction where it's talking about our learning objectives. This, I mean, 2 minutes, really, that was probably what, like 30 seconds. But when we start creating things, we have cool interactive videos here, which, oh man, looks like it's not loading for us now, but you'll see kind of intro videos to Xamarin, explains all the things to you. What is Xamarin Forms? Don't worry about that because you're already experts on Xamarin Forms now because you came and joined us today. And then here's how to get started. So here's how to create that project in Visual Studio. Here's what these projects look like. A lot of the things we covered today, then here's all that code and all this fun stuff. So if you are interested in learning more about Xamarin, which hopefully you are, it is an amazing platform. I love it. I'm also super biased, but trust me, you won't regret it. You can check it all out on Microsoft Learn. So if you haven't had a chance yet, make sure to grab this link, codetraveler.io/Xamarin-conf. This is the webpage where you can find everything we covered today. So you can find links to the recording, you can find links to the, you can find links to the slides, you can find links to Microsoft Learn, you can find links to the open source code samples we went through, you can find links to the Xamarin libraries on GitHub. Anything we talked about in the talk today, it's all right there. Make sure to bookmark that, share it with your friends, share it with your coworkers, anybody who couldn't make it to today, but maybe is also interested in Xamarin. And thank you.
Thank you. And we do have a couple questions if you have a few minutes.
Yeah, of course.
The first one is, can you make Xamarin Forms apps in VS Code?
So right now, I recommend using Visual Studio. The Microsoft it's people way smarter than me, are working on making a better Xamarin experience in Visual Studio Code. So to answer your question, yes, you can totally write all of your code in Visual Studio Code, but some of those developer tools, for example, like to launch the app on the iOS simulator, you'll have to know the command line commands to do that manually yourself. Whereas if you're making it in Visual Studio, it's just click the run button, the simulator will pop up, the app will get loaded onto it. So we are working on that, and there is a next round of .NET coming out. The preview should be coming out soon, called .NET 6, and we plan on having better support in Visual Studio Code in .NET 6, and it'll only keep getting better as .NET 7, .NET 8 come out. So if you are planning on firing something up today, highly recommend using Visual Studio. Can you do it in Visual Studio Code? Yes, but it's going to be a little bit harder. It's going to be a little less pleasant than if you were using Visual Studio or Visual Studio for Mac. But stay tuned, because really smart people at Microsoft, smart engineers, are working on making that a better experience.
Awesome. And then the next question is, what is the reach for Xamarin apps with regards to OS versions?
Let's see. I'm not sure exactly. Let's see. I'll answer, because I think that could be two things. Like what mobile or what platforms can you target using Xamarin could be one way to interpret that question. And iOS and Android are our kind of first class platforms. But actually, let me back up. So Xamarin, Xamarin just wraps all the iOS APIs, all the Android APIs. So if we're talking Xamarin, that's focusing on iOS and Android. Now Xamarin Forms, because that's just a UI framework, it works on iOS and Android, but it doesn't just have to work on iOS and Android. And Xamarin Forms, you can actually target Windows using UWP or WPF. You can target Linux using GTK Sharp or GTK Plus. Hopefully I'm saying that right. You can target Tizen, you can target macOS, and more. So yeah, if you're creating an app in Xamarin Forms, you can target a bunch of different platforms, and then Xamarin is basically just the API wrappers for iOS and Android. The other way to answer that question is, what platforms can you use to create Xamarin apps? So if that's what you meant by the question, then Windows or Mac OS. So Visual Studio in Windows to create your Xamarin apps in Windows, or Visual Studio for Mac to create your apps using Mac OS.
All right, thank you. And then the next question, how do you publish apps outside of app or Play stores?
Oh, well, that's a good question. So kind of two parts to that question. The first one is, why are you doing it? The most common reason to do that is maybe you've made an app that is only for your company. Like I've worked at companies where we had a HR app and it was only for the employees of the company. So they wouldn't put it in the app store. They would have their kind of almost like little mini company app store. So when you got your company phone, you could download the company apps, yada, yada, yada. That's called an ad hoc distribution, because you're not going through a store. And the way you do that for Xamarin apps is the same way you do it for, we'll say, non-Xamarin apps. So if you created the app using Xcode, Swift, Java, Kotlin, it's the same story. You basically just would publish the app and have to have some sort of hosting service. I would recommend using something like TestFlight for iOS, or the Google Play Store has its own I don't think I have a name for it, but the Google Play Store allows you to just publish internally as well. There's also a bunch of other tools like App Center Distribute, or I'm blanking on it, but there are tools to distribute your apps. And if you want to publish your apps to the app stores, the official app stores, then again, it's the same exact way. They're just native apps, so you use all the Apple's app publishing tools, all of Google's app publishing tools. And I guess there is a third option, because, well, for iOS, there's only the App Store. But for Android, there are a couple Android app stores, like Amazon Fire, I'll say definitely used to. I'm not sure if it's still around, had their own Fire store. There's other, like, we'll say untrustworthy stores that I don't really recommend pushing to, but you can do that. But yeah, I mean, the TLDR of it is it's the same exact way you would do it for native apps, because they are native apps. So you would use Apple's tools, Google's tools, and use those for all your distribution.
All right. And then the final question that we have right now, and you may have touched on this a little bit before in the first question, but it says anything in Xamarin related to coming .NET 5 and 6. So I'm wondering if they're asking about like the upcoming versions.
Oh yeah. Like what's coming in .NET 6. So .NET 6 is actually really exciting for us Xamarin developers, because there's a couple things going on. Under the hood, Xamarin today runs on the Mono runtime. Mono, if you've never heard of it, was a open source cross-platform implementation of .NET that started probably 20 years ago. Basically, some developers in the community reverse engineered .NET and created Mono. So it was the first way actually to create iOS, or to create C# apps that ran on Linux and Windows. Fast forward to present day, there's also .NET Core, which basically does the same thing, right? There's some benefits for both, and we won't go into those, but in .NET 6, we are merging Mono with .NET Core, so we're getting all the good bits of both together. And so what that means is you'll get, we'll say better support, although that implies that Xamarin has bad support right now, which it doesn't. But for the engineering side, right now we have to add new features to .NET Core and Mono at the same time, or in parallel paths. Whereas once those code bases are merged together, which they are/will be in .NET 6, then we'll be able to iterate faster on the engineering side. And then there's also something called .NET MAUI, which is the next iteration of Xamarin Forms. So we are basically taking Xamarin Forms, so that concept of sharing UI code, and we are re-architecting it. So we're making a lot of breaking changes to Xamarin Forms and taking this opportunity to rebrand it as .NET MAUI. MAUI just stands for Multi-Application User Interface. And so Xamarin Forms will essentially be rebranded as .NET MAUI, and we're revamping the architecture. You know, Xamarin Forms was created 6 years ago, and we've learned a lot of stuff along the way. Plus, by re-architecting .NET MAUI, so not only will it be better, faster, easier to use, more performant, all those benefits, but .NET MAUI will also let us expand to more platforms. So right now, like Xamarin Forms doesn't work for websites, but .NET MAUI opens up that opportunity to have a Xamarin Forms app that runs on iOS, runs on Android, runs on Windows, runs on macOS, and runs in the browser. Now, when .NET 6 comes out, it won't have support for the browser, but we now have the ability to do it. Whereas with Xamarin Forms today, we're kind of locked into this old architecture. So yeah, .NET 6 has a lot of really cool things coming. Plus, we're going to be working on some more Visual Studio Code support. We'll have better .NET command line tools for Xamarin. So yeah, lots of cool things coming with .NET 6. So keep your ear to the ground. There should be some .NET 6 announcements, we'll say early this year. So in the next few weeks, next few months, we should have a .NET 6 preview available for everybody to play around with. And it should be pretty cool. So lots of performance improvements, lots of tooling improvements, and just better things all around for Xamarin and .NET 6.
All right, perfect. Thank you so much. Well, that was it for all the questions. Thank you everyone for joining us today. And as I mentioned in the beginning, there's some links in the Q&A for the Reactor YouTube channel where you can find the recording for this event as well as some of our other past events, our meetup page where you can find more upcoming Reactor events, and then I will add the final link, which will be the link to the survey. If you do have a few minutes to fill it out, that would be great. And thank you, Brandon, so much for putting this event on today.
My pleasure. Thanks for having me, Dion, and thanks everybody for coming out and hanging out with us today.